Hi there, this is just Mr. Wee. I'm just going to go over pH and pOH. So part 1 right now, it's just going to go over like concept before you get into the calculations. Because especially if you're going to study for the test, you're going to know what to do a lot better if you understand the concept. Part 2 is just calculations, so just be warned, if you're just going to study part 2, you're not going to get that far for 1 in the test, and 2 in science if you want to be a science or do anything in science or medical in the future. Okay, so it helps that you actually know what you're doing here. Okay, so before we move on, let's look at HCl and NaOH, and please try not to look ahead. Just focus on this so it doesn't confuse you. Okay, that is a strong acid. How do I know it's an acid? I've already taught you guys to kind of recognize that if you just see an H component with the HCl, or like any other guy, an H component in there, it's an acid. It's a pretty strong acid. And if you see NaOH or anything with OH in there, most likely it's going to be a base. Okay, this is our understanding of bases and acids at this point. And plus, these are really strong acids and bases. And the reason why I say they're strong is because, let's say you had hypothetically in a test tube like 1,000,000 molecules of these guys. All 1,000,000 are going to break completely apart into an H ion and a Cl ion. Okay, what I mean by ions are individual atoms with charges right there. So these are atoms with charges. Okay, that's a strong acid. A weak acid would be like, let's say we had 1,000,000 of these guys floating around, only half of them would like break apart completely. Okay, that's what I mean by breaking apart completely. Same with the NaOHs, that's a strong base. So if I had like 1,000,000 molecules of NaOH, they would actually all complete, like all 1,000,000 or about 999,000 or so, would actually completely break apart. Okay, and that's really strong because if you break it apart, then it's going to have really bad effects on whatever you put it on. So that's why be careful of strong acids and bases. Okay, so if you recognize this, what's going to happen is these guys are going to collide and react, and they're going to dissociate. So like HCl is going to dissociate into H, and Cl, Na and OH are going to dissociate. And what's going to happen is they're going to swap partners. Okay, so we have a that's an acid ion, and that's a basic ion. So we know the OH is a base. That's an acid. So what's going to happen is these two that I circle are going to come together, and guess what? A strong acid, a strong base, if they come together, they're going to neutralize, and they're going to become water. Okay, simple as that. And OH plus H is H2O. Get it? So now it's neutral. Okay, and the leftover Cl and the leftover Na, guess what? They're going to come together to make a salt. Okay. Usually the leftovers, if it doesn't have any H's or OH's in there, we just call it a salt. And in this case, we know that as table salt. Okay, it's not always NaCl. It could be like KCl, or depending on the reaction that we have, like depending on who's here, like in the reactants. But we always have a salt. So that's typically what happens. You add a strong acid, a strong base, you get a water, and then you get a salt. Why is this important? Because essentially what I want you guys to know is that the H and the OH essentially come together to make water. That's a really, really important relationship to understand when you're talking about this stuff. Okay, so let's go over that. Hopefully it's not too new to you. Okay, so there's pH. Here's we talk about everything in terms of acidity. We attribute it to the pH scale. So if you guys remember, the lower your pH, you're acidic, like 0 to 6. The higher the pH number, the higher the pH number, the more basic you are, 8 to 14. If you're in the middle, 7, you're actually super neutral. Okay. All right. So there's by the way, these are all of your notes that we had, slides. So you can actually check them out online if you want. If you go to the Unit 8 tab in the chemistry website. So go ahead and don't focus on this. Just look at this relationship. H2O can actually break down to an H plus ion. That's an acid ion, and a base ion. If you want to know the nitty-gritty details of what this means, come and see me after class. Otherwise, let's just stick to this really quick, okay? That's a very important relationship. Okay? Again, you see, it's an acid ion and a base ion. Okay? The truth is, let's say we had like a lot of H2O molecules floating around. We should have, okay, like let's say this is very acidic, right? And this is super basic. We should have an equal amount of acids to bases to neutralize to come together to make H2O. Because if you take the pH of good water, it's like 7, right? It's neutral. It should be 7. So take that in consideration, because think about that number 7 and see how it kind of relates to this slide here. This is a very important slide. Now, we talk about the amount of ions. Okay, we talk about an amount. And theoretically, if I had, let's say, like a bunch of H2O guys, the concentration in, like, let's say like a cup, okay, the concentration of H plus, like the amount basically of H plus ions there are should be the same as the amount of OH ions. We should have the same amount of acid ions as there are to bases, so they can come together to neutralize to make water. Okay, and when I talk about concentration, I'm talking about these things in brackets right here. When I put brackets around anything, I'm talking about the concentration, or basically the liquid amount. Okay, when I'm talking about an amount in terms of a liquid, I have the concentration of H plus should be the same as the concentration of OH. And I actually wrote that. Concentration of H plus is the same as the concentration of OH, which is actually equal to this weird number. 1 times 10 to the negative 7th molarity. Okay? That's the concentration, and they should be equal, right? Because if they come together, there should be an equal amount coming together to make neutral water, right? And perfectly neutral water. Okay? So just remember that number there. Think about it. pH, okay? pH 7 with water, neutral water, and then we have suddenly this number. Think about that. That's not a coincidence, okay? So anyway, here's the thing. This is what you need to know. It makes a constant value. If I take the concentration value of H plus and I multiply it to the concentration of OH minus, if I take those two concentrations, which let's say they're both equal to this, if I take those and I multiply them, I actually get 1 times 10 to the negative 14th, okay? And the truth is, even if I have a solution, let's say, where I have more H's and I have less OH's, guess what? In science, okay, theoretically, it doesn't matter what the concentrations are. If I have more acids and I have less bases, that number, if I multiply them together, it's still going to be 1 times 10 to the negative 14th, okay? Okay, so let me kind of slow that down. Again, let's say if I had like a liquid, right, where I had a bunch of OH guys, making it more basic, and I have a lot less H plus guys. The truth is, if I ever multiply their concentrations together, theoretically, it will come out to this number. So it actually doesn't matter that they're the same value in water. This is just water. It could be any other liquid, pretty much, if there's H's and OH's involved, okay? If there's H's and OH's involved with any liquid, if I multiply them too, okay, you're going to get this number no matter what. If I have a ton of acid guys, but I have less basic guys, guess what? If I multiply their concentrations together, I'm going to get this number. 1 times 10 to the negative 14th, okay? So essentially, to continue on with that, the H plus and the OH can actually change if you have an acid, or if you add an acid or a base to a water, but it really doesn't matter. That Kw will always stay constant. Okay, so let's transition to pH and pOH. Okay, I said pH and pOH are essentially just logarithmic values used to express the H plus and OH minus, the OH minus concentration. So what I mean by that is, let's see if I can. Yeah, let's just go right into that right now. Okay, so what I mean by that, actually, let's just continue this on in part 2. Okay, I'll see you in part 2. Okay.